All right, so the first thing, just a basic overview for the quiz. You've dealt with this a lot if you've done the packet, but when you have log little a of b equals x, that is obviously called the logarithmic form. Okay. And then if you have a to the x equals b, that's your exponential form. Now, sometimes these conversions, you can obviously see the letters and where they go. So we've talked about that before, where the matching pieces go. You know, your B in the original is going to be the B over here. Those match, and the A's match, and the X's match. But what I wanted just to notice is the terms of here. So a logarithmic function and an exponential function are inverses of each other. So when you're given a function, if you're asked to convert a logarithmic function to an exponential form, you're basically finding the inverse. Before this one, all the inverse practice we did for a month ago, we were like, find the inverse of x squared. And you're like, oh, square root of x. You don't realize it, but you're actually finding the inverses of each other. So I just felt like that some of the verbiage on the quiz, when it says find the inverse of this exponential, you convert it to logarithmic and you found the inverse. Does that make sense? So they are inverses of each other. So let's try a couple here. All right, what if I said we have log base 4 of 64 equals 3. So they would ask you to rewrite it as an exponential. Also, that means find the inverse. Now, in a way, you're not really finding much, like you don't have to like do any solving like a linear equation anymore, but you're going to rewrite it as an exponential. This is a logarithmic function, and when you turn it into an inverse, then that's writing it as an exponential. So let's see. Remember, you've got a number, a power, and an answer. So my base is this guy. My exponent is the answer. It's the output from the log function. It's the input of the inverse exponential. And then my output on the exponential would be the input of the log. And you can verify that 4 to the third does equal 64. So it makes sense. It's almost kind of weird because you don't feel like you're solving anything with this. They're just telling you 4 to the third power is 64. That helps you understand what the logarithm is representing, but then now you rewrite it like this and it really says that. So just make sure you can use that pattern. You can rewrite a logarithmic as an exponential or vice versa. You're good to go. And remember, you just found the inverse function. Okay. Let's try another one. I've got 3 more here I want to show you. So if I said 10 to the x equals 12.2, they would give you something and tell you to solve it. Okay. So you could do guess and check. You'll have a calculator. You could do that. You could type it into Desmos. Okay. And so you have 10 to what power equals 12.2. If you had 10 to the first, you know that's 10. And 10 squared equals 100. So you know it's somewhere in between 1 and 2, right? So in order to solve this, we need the book or how the packet explained it to you was that you want to turn it back into a logarithmic function. Again, if you can guess, and some of these on the quiz are multiple choice or fill in the blank or matching, you can guess and check it if it's there. But you know it's not 1 because that's too low. 10 to the first power would be 10 and 12.2 is bigger than 10. But you also know it's not 2 because that's way too big. So you could guess and check, or let's turn this back into a logarithmic. So we'd have log, my base is 10, my 12.2 comes here, equals x. You can type this right here into your Desmos or your calculator. The Zoom on Tuesday, we talked the other day that if you're on Desmos, this little base thing comes up. You have to go to the Desmos screen and type or look on the, when you're going to graph something, get the keyboard to come up. And when the keyboard comes up, you'll see a little functions tab on the right. Click on that and it's under miscellaneous. I can't share that screen just right now with you, but maybe at the end I'll show you in Desmos. But you type in under functions and then it's miscellaneous and it'll have a basic, it looks like this. It has log little a. So if you pick that one on Desmos, you can basically type in everything and it will solve it for you. But the cool part about this is you don't even need Desmos. See how this is a 10 here? If it is a base 10, that's the only one your TI calculator can do for you without, just like when you type it in. So I actually can just hit the log button on a regular calculator and type 12.2 because when you type log, it assumes base 10. That's how they work. So you should get 1.08, I'll say a couple decimals, 6. On the quiz, if it's 1.08, great. A 1.09, fine. Like I'll get what you're typing. 1 would be a little bit suspicious. Like I wouldn't just put a 1. Don't round to the whole number here with 1 because that's going to be like 10 to the first power is not going to be 12.2. And that should make sense because it is really close to this 1 up here, 10 to the first power. We only wanted to get to 12.2. So that's why that number is so low. Okay. All right. Another thing real quick. On the quiz, don't forget about negative exponents. So when you have 10 to the first power, that's 10. And when you have 10 squared, that's 100. But what's 10 to the 0 make? Well, that's just 1. Looks like an I up there. Sorry, that's not a Y. That's not an I. But if you add 10 to the negative 1, it does not equal a negative number. It's actually 1/10. That goes back to those exponent rules where it would go in the, if it's not happy up top, you'd push him in the denominator down the basement and he becomes a positive 1 right there. You could write it like that. Or 10 to the negative 2 is 1 over 10 to the positive 2. So, or 1 over 100. Okay. So just don't forget about negatives because there's one that kind of looks like this. You get a true or false. Here is the statement. Log of 1 over 100 equals 1/2. So this would be like what a question might look like on the quiz. True or false? Now, could you use a calculator and tell me if it's that? Sure. Like you have a calculator on your quiz. No one's watching you there. But let's think about this. If I convert this, if we don't have a number down here in this spot right by the log, remember that's a 10. So that means 10 to the power of 1/2 would equal 100, or 1 over 100, I'm sorry. That's when I convert that to the exponential. We need to answer, is it true or false that this is the case? Well, 10 to the 1/2 power, if you try that, think about that's not going to be 1 over 100. As a matter of fact, look at right up here. Here's 1 over 100. These match. If you wanted to get 1 over 100, your power would need to be -2. So all of that work for when you could have guessed 50-50 chance, true or false, that one's false. Because I've converted this log statement here that they gave me to an exponential, its inverse, and it did not turn out true. And again, you could type in that log thing on your calculator, log of 1 over 100, and it would not be 1/2. So you'll get a true false kind of thing or a multiple choice just to look on there and say, okay, is that a true statement or not? And then use those conversions or your calculator. Okay, last one, and then I'll open up for questions here. Let's see. So something like this. Log of 3x plus 1 equals 2. So to solve this, you need to again do that exponential conversion. They don't always tell you to convert it to an exponential, but if we do, it's going to make it a lot easier to solve. So remember, there's no number down here, but I'll sneak it in. It's if you don't see a base number down there, it's a 10. So to rewrite it from that first slide, I would have 10 from here to the power of 2 equals 3x plus 1. And again, just that pattern of putting things where they're supposed to go. It's like putting everything where they go in the opposite form. Now we would solve this. So 10 squared makes 100. And I bring down my 3x plus 1. And then just solve it like a linear equation. So I'm going to go ahead and subtract 1 from both sides. You get 99 equals 3x. And then I'll divide by 3 on both sides. So my x would be 33. Okay, so that's one of the solving ones, and there is one of those on the quiz. Okay. Okay, so we're going to look at the Friday assignments from the packet on Plan Book, number 2, yada yada, bacteria, gross, disease, coronavirus, whatever it says. They want you to find the error in all of this person's work. So we need to remember that over here, when you have this little a in the base, it goes first. When you have the b in the input of your log, it's what answers your exponential equation. And then the answer for your log is the power of your exponential. So let's follow along. The first thing they appear to have done in the first step is divide by 100. So if I look here and they divide by 100, to get that 10 power alone, if I divide by 100, it is true that 2,500 divided by 100 would make 25. So this step checks out. They did a good step from there. Then they need to use this guy over here. This is where we have the problem. So they kind of wrote it backwards, but this final output right here, this final number without the exponential is like this b value here. That needs to go right there. So it should really look like a 25 here. I'll write my log. And then the base of the exponential, this 10 here, if we look here, there's a base over here on my original little conversion. That's the little base down here. So they have that 10 in the right spot. And then finally equals the x should be the exponent. Well, the exponent is this. So here's where they made that mistake. This is the bad step. They put the 10 in the right spot, but they did not. They mixed up the 25 and the variable t. And now I should probably put a t there if I'm going to stay uniform. That's a t. And I really messed it up, but you know. So right there. Now from here, they would just have to keep solving it by using a calculator. They seriously just need to type log of 25 on their calculator. And if I do that, they should get 1.398 for their value of t. So once they went wrong on this third step, that would give them a whole different answer.